Chapter 5, the Skeletal System, Screencast 2. Now, this particular screencast is focusing on that concept that I introduced earlier about plasticity. So keep in mind here we're talking about the fact that bone is living tissue and it is especially responsive to external forces. And the term we use for that is remodeling. And remodeling is kind of defined as the changes that occur in shape, strength, size of our bone. Now, this is going to be very dependent upon a number of factors. Our age, how much activity we get, and the type of activity, and also diet. Now, what we do know, weight-bearing exercise increases overall bone mass and strength. The term that I'll use here is loading bone. So that is the type of force that results in new bone growth or an increase in bone density. So that's a really important thing to remember here. Okay, so high impact activity, that really is the type of exercise that is going to benefit the skeleton the most. So not just weight bearing, it has to be of a high impact nature. So let's keep that in mind. Now, when we look at the homeostasis of bone, it's dependent upon the balance of the activity of two cells in particular. And these cells are osteoblasts and osteoclasts. Now, osteoblasts, we saw previously, they are actually responsible for the formation of new bone. Now, osteoclasts are going to be breaking bone down to make calcium available. We regulate calcium levels in our blood pretty tightly, and we need to keep in mind we've seen a number of things along the way where calcium is necessary. So I can't have synaptic transmission, I can't have muscle contraction. So calcium is very necessary for a lot of important functions. Now, many of you are familiar with the disease osteoporosis, and this is overall a decrease in bone mass, and it's an imbalance in the activity of our bone cells. And what's happening here, the osteoclasts are more active than the osteoblasts. So you have a loss of balance in this situation. Now, as talked about previously, constant remodeling is going to impact our bone shape. I said this earlier, compressive stress, what it does, there's these electrical currents that are created in bone, and these currents actually stimulate the osteoblasts. What's going to happen here is new bone will be deposited in those areas of the highest compressive forces. Bone will be resorbed in areas of low compression stress. And as indicated before, weight bearing, especially high impact exercise, increases overall bone mass and strength. Here we can basically look at what's happening. So as I said before, long bone in particular, compact bone, is very responsive to compressive force. And what we're going to see here, the application of force, and bones aren't completely straight. There's a little bit of a slight bend. And what happens, there's going to be a greater force on the inside curvature. Okay, and we can see that here, and a less force. Okay, and what's going to happen here, basically across time, bone is going to be added here, where the stress is the greatest, and we're actually going to remove bone from this area, but remember, it's not being loaded. And the final result overall is a bone matched to the compressive force to which the bone was actually exposed to. Now, as I said before, the cells that are involved in this process are really critical, and we've introduced some of them previously, so this is definitely something that you do need to be familiar with. Chondroblasts, those are cartilage forming cells. Now, blasts, you're going to see immature cells. So osteoblasts, these are young bone forming cells. Osteocytes, these are the mature bone cells themselves. And then we have osteoclasts, and those are the cells that actually dissolve bone to make calcium available to our bloodstream. Now, when we talked about hormones within the endocrine system, we talked about parathyroid hormone and calcitonin. So this is something you should be comfortable with and being able to describe how these hormones work and what causes them to be secreted. So that's going to be important. So parathyroid hormone. The secretion of parathyroid hormone increases when blood calcium levels start to fall or decrease. This will actually stimulate the osteoclasts to secrete more bone-dissolving enzymes to increase blood levels of calcium. Calcitonin, this hormone is going to be secreted when blood levels of calcium are high. This is going to stimulate the osteoblasts to add calcium and phosphate to bone. So you definitely want to be comfortable with these two hormones and how they work and what is their primary stimulus. Now, many of you have probably fractured a bone. So bones have that ability to heal. Now, there is an animation that I've not included, but it is available on the animation PowerPoint or in the main PowerPoint. But let's kind of go through the processes here. Okay. Now, one thing that we do know is once a bone heals, it's actually stronger at the site of fracture. Okay, so let's keep that in mind. So originally, there's a fracture or break within the bone, and what's going to happen at the site of fracture is the formation of a hematoma. Now, fibroblasts, they're going to migrate to the area of injury, and they're responsible for the beginning of the repair process. Now, what's going to be formed at the area of injury is a very tough fibrocartilage callus, and that's actually produced by the chondroblasts. Now, osteoclasts, they're going to be responsible for removing dead, damaged bone and the remnants of that hematoma. Osteoblasts will be responsible for depositing new bone in the area of fracture, and depending upon the bone, how serious the fracture was, this can actually take from weeks to months.